Hello, thanks for accepting this work. We will present this work under the title
Study of deposition temperature on the physical performance of the structural and morphological properties of the films. Abstracts. This work aims to study the effects of heat treatment, annealing, on the morphological and structural properties of the film prepared by chemical bath deposition method of powder consisting of oxide sodium bicarbonate, copper oxide potassium chromate, magnetic sample rock on glass floors at different temperatures and in magnetized medium. Introduction. The nature of the deposited material in the form of thin films is an important way to know many of the properties that are difficult to obtain and that differ from the properties of the materials that make up them while they are in their volumetric state. The fact that its thickness is infinitely small and its large surface to volume ratio give it a unique physical composition, and by using metal oxides it improved the electrical, optical, and structural properties, making it the most common technology in the electronic industries, including transistors, pumps, and sensors. They were used to compensate for some parts of the electrical circuits such as integrated circuits and resistors. Conclusion. During this work, we were able to study the surface structure of the prepared films, and through scanning electron microscopy, it was found that it consisted of a heterogeneous granular structure in terms of size and dimension, and that all of these films were of a non-structure. It was also shown that sedimentation leads to an increase in the particle size, and that the average size of these particles has an effect on the density of the distribution of the membrane material. The change in the size of the particles in terms of the setting temperature was studied. An increase in the size and density of the particles was found for the prepared film at 200 degrees, while the sedimentation rate decreased with a greater increase in temperature, as we find that the typographical surface of the membrane depends mainly on the sedimentation temperature and the extent of the solution solubility in the powder. It was found through ADX analysis that the structure of the products is composed of chemical elements calcium, potassium, gold, silicon, aluminium, sodium, oxygen, and carbon at different temperatures, with the presence of the elements palladium, promethium, magnesium at 150 degrees, and at 200 degrees appearance of an element niobium, magnesium, and at 300 degrees appearance of an element copper, promethium, and manganese.